Good morning, class. We are going to turn to page 60 and work on the warm-up. Okay. All right, so we're going to divide this polynomial. Again, I'm just going to use the box method. I'm going to make sure that I don't need a placeholder, a 0 for a placeholder. So I'm going to count 3, 2, 1, 0. We're good. The denominator has a binomial and it's in standard form. All right, so I'm ready to use my box method. 2 rows. Plus 1. Then we have x cubed, 5x squared. Oh, that was a fancy x. I'm going to make a column. And I have my 7x. And I need one more column for my constant term, 5. Okay. Have your division thought. X cubed divided by x is x squared. And if you want to do long division with this problem, you can go ahead. I'm sure you'll get the same answer if you're acclimated. X squared times 1 is x squared. Okay. This box plus this box need to add up to 5x squared. So that's 1x squared. So 4x squared plus 1x squared gives me 5x squared. All right, have your division thought. 4x squared divided by x is plus 4x. Multiply back. 4x times 1 is 4x. And then this box plus this box need to add up to 7x. So 4x plus 3x gives me 7x. Have your last division thought. 3x divided by x is plus 3. Multiply back. 3 times 1 is 3. All right, we have a remainder. And remember to find the remainder. You take the outside, you subtract what's on the inside. And 5 minus 3 is 2. Okay, so remember we have to write it in this form. Quotient plus remainder divided by the divisor. Okay, so our remainder is x squared plus 4x plus 3 plus 2 divided by x plus 1. Okay. What does the result tell you about the relationship between the expressions in the numerator and the denominator? Okay, so today you will learn, or you should have learned, that when I divide and get a remainder, the result tells me that x plus 1 is not a factor of x cubed plus 5x squared plus 7x plus 5. Okay, so please make sure that you write this down. Take a second, write this down. When I divide and get a remainder, the result tells me that x plus 1, that is your divisor, is not a factor of this polynomial x cubed plus 5x squared plus 7x plus 5. Okay, so anytime you get a remainder, it means it's not a factor of the polynomial. Okay, if you want to hit the pause, I'm going to move forward. If you want to hit pause and write the rest of this down, otherwise I'm going to move forward. Okay, on page 61, you might want to hit pause here and go ahead and do this page on your own. Otherwise, I'm just going to write the answers. All righty. 11 goes into 32 twice. And that would be 22. Subtract. You're going to get 10. Bring down the 5. Now 11 goes into 105. Well, 9 times 11 is 99. And we have a remainder of 6. So 29, remainder of 6. Righty. You're going to need these answers for the next page. 12 goes into 32 exactly 2 times. Well, not exactly, but 2 times. And that's 24. Subtraction there, sorry. And then that's going to be 8, bring down the 5. And 12 goes into 85 7 times. So 7 times 12 is 84. So subtract 84 from 85, you get 1. So we have a remainder of 1. All righty. 13 times 2 is 26. And so that's going to give me a remainder of 65. Oh, 13 goes exactly into 65 5 times. So 0. No remainder. All right, let's get back up to number 4, long division. 2x squared divided by x is 2x. Multiply back, you get 2x squared. Time 2x times a negative 2 is negative 4x. Sorry, I'm on a mouse, so I'm on a Mac, and so I'm using the little mouse pad, and it's hard to write with. All right, these cancel out. Remember, this is 1x minus a negative 4. I'm sorry. Yeah, negative 4x. So that's going to go to plus. So it's like saying 1x plus 4x, and that'll give you 5x. Bring down the negative 21. Have your division thought. 5x divided by x is plus 5. Multiply back. 5 times x is 5x. Oh, it's a fancy 5. And then 5 times a negative 2 is negative 10. Again, you're going to subtract. 5x times minus 5x is 0. Negative 21 and negative times negative, so that's going to go plus. So it's going to be negative 21 plus 10. So that is going to be a negative 11. So we definitely have a remainder here. Okay, we're going to do the same thing. Again, you should pause the video and do this on your own. Division thought. So you get 2x, multiply back, 2x squared. Two x times negative 3 is negative 6x. Subtract, cancel. All right, negative times negative is going to give me a positive. So I'm going to go ahead and change that. It's 1x plus 6x gives me 7x. Minus 21. 7x divided by x is plus 7. Multiply back, we get 7x. And then we get a negative 21. 7 times a -3 is -21. We're subtracting, that cancels out. This is going to turn to a plus. Oh, have no remainder. 2x squared, -8x, subtract, cancel out, turns to a plus. That's 9x minus 21. 9x divided by x is 9. Multiply back, we get 9x. Minus 36, because 9 times a -4 is 6. Subtract, cancel out. These are going to adding. And -21 plus 36 will give us a positive 15. So we have a remainder of 15. All right, now you may have to flip back and forth. We need these answers to answer the next page questions. So on page 62, here it says use the divisor times the quotient plus the remainder, where D is the divisor, Q is the quotient, and R is the remainder. All right, so this would be problem 1, 2, 3. Our divisor was 11, so we'll take 11 and multiply it. You can use the dot, parentheses, whatever your choice is. But now our quotient was 29. And then we had a remainder of 6. All right. I would highly recommend that you pause the video now and go and complete the next two on your own. All right. Our divisor was 12. Our quotient was 27. And we had a remainder of 1. Okay, here. Divisor was 13. Our quotient was 25. And we did not have a remainder for that one. I'm sorry, guys, my internet's going out, so I got booted off of Zoom. So hopefully I don't know where we left off, but I don't know where it stopped. So hopefully you got to do 7 and 8. All right, I'm just going to recap 8. The divisor was 13. There was no remainder. So this must be a factor. This divisor 13 is a factor. Okay. When it has no remainder, it is a factor. When it has a remainder, it's not a factor. All right, use the result from problem 436. So this is 4, 5, 6. To write the expression, P of x equals 2x squared plus x minus 21 in the form x minus a times q of x plus r, where x minus a is the divisor, q of x is the quotient, and r is the remainder. All right, simple enough. We're going to write it here. P of x equals the divisor of x times q of x plus r. Okay, so we had a divisor of x minus 2. And we're going to multiply that by our quotient that we got. And that was 2x plus 5. And then our remainder was minus 11. I would highly recommend you stop the video and try 5 and 6 on your own. Okay, our divisor was x minus 3. Our quotient was 2x plus 7. And we did not have a remainder. All right, the next one, x minus 4 was the divisor. We're going to multiply that by our quotient. And that was 2x plus 9. And then we're going to add our remainder, which was 15. Okay, hopefully you're stopping the video and answering number 10 on your own, and that you said x minus 3 was a divisor of that quotient, because again, we had no remainders. Okay. All righty. Okay, so in number 11, it says use this expression p of x equals x minus 2 times 2x plus 5 minus 11 to find p of 2. So what you want to do in this case is you just want to substitute in 2 wherever you see x. So this would be x, 2 minus 2 and 2 times 2 plus 5. And then I'll subtract 11 by 11. Well, I see something here in the first parentheses. Well, 2 minus 2 is 0. Since 0 times anything is just going to be 0, all that goes to 0. And then 0 minus 11 is just negative 11. Okay, so I would hope that you would stop the video and do 12 and 13. You can just evaluate each one of these independently. And I'm not going to do all the work here, but I am going to put the answers. And so once you do that, you'll realize that one will equal 0. And this one would equal 36. Okay. Number 14. If p of x equals x minus a times q of x plus r, then p of a equals r. Just equals the remainder like it did in number 11 and then in number 13. Okay, for a polynomial p of x and a number a, the remainder on the division by x minus a because this would be a factor. And when I set that equal to 0, right, I'm going to add a to both sides. So that's what that means. And then a's cancel out, and then x would be equal to a positive a. So therefore, p of a. This result is known as the remainder theorem. Okay, if p of a equals 0, then x minus a is a factor of p of x. Okay, just like we got in number 12. We found out that x minus 3 is a factor of 2x plus 7, or I'm sorry, of the quotient p of x, 2x squared plus x minus 21, because we had no remainder. Okay. This result is known as the factor theorem. Okay, and remember, this just means you founding the x-intercepts when you set it equal to 0. So x-intercepts, roots, zeros. You got it. All of them. Solutions, roots, zeros. All right. Okay. Hopefully you understood that. And let's just go to the next page, which will be page 63. All right, consider this polynomial. And verify that f of 1 equals 0. So again, you are just going to evaluate. You're going to plug in a 1 wherever you see x. So that's 1 cubed minus 1 squared plus 4 times 1 minus 4. And if I evaluate this, I know I get 1 minus 1 plus 4 minus 4. And I can verify that it does equal 0. Okay. Since f of 1 equals 0, f of x must be divisible by x minus 1. Because if the solution, and I'll go ahead and write this so you understand this concept. If the solution is x equals 1, then if I subtract 1 from both sides, I can find the factor. X minus 1 equals 0. So that's the factor. Okay. You just go backwards. Okay, now use the polynomial division to write the factorization. Factorization to the equation f of x equals. So we're doing two things. We're writing this in factored form. And I'm getting a message that my internet is unstable, so I hope you're hearing me. So we're writing this polynomial in factored form, and we're going to find the solutions. Okay, so we know that the divisor, so x minus 1 is the divisor. Okay. Let's just do this the box method. X minus 1 is in standard form. I do not need a placeholder in my divisor. Let's just see if I need one up here. So we're going to take our dividend. This is our dividend, and we're going to plug it into our box. So we get x cubed, and then we have x minus x squared. And then we're going to have our x term. We got plus 4x. And I need one more column. And I'm going to have x, minus 4, negative 4. All right, let's have our division thought. X cubed divided by x is going to give me x squared. Multiply back, x squared times a negative 1 is a negative x squared. Oh, all right, this box plus this box need to add up to negative x squared. So this must be 0. All right, that works. 0 divided by x is still 0. All righty. And now we can multiply back, and that's going to give me 0. All right, this box plus this box need to add up to 4x. So this has to be 4x. Division thought, 4x divided by x is plus 4. Multiply back, 4 times a negative 1 is negative 4. And I can see that these are the same, negative 4 and negative 4. So I have no remainder. All right, so that's good. So x minus 1 must be a factor of this polynomial. All right, so now I can go ahead and write my factors out. I don't need to write the 0 in here, which is just a placeholder. So here are my two factors, x squared plus 4, and then x minus 1, because that's what I'm dividing by. So it must be a factor since I did not get a remainder. Okay, set those both equal to 0 and solve. All right, let's take this one, x squared plus 4. I hope you're noticing something with this one. And we set it equal to 0. And then we subtract 4 on both sides. And we get x squared equals a negative 4. And we take the square root of both sides. And we're left with x equals plus or minus square root of 4 is 2i. All right. Now, when I bring this one down and solve this one, remember, you have to take this as a factor, right? That's what we just learned. It is a factor. X equals 1. So I have my solutions. And one thing I want to point out is that we started in this standard form. We started with x cubed. This tells me how many solutions I should have. I should have 3 solutions. And let's go count. I should have 3 complex solutions. And so remember, all the numbers fall under the complex number system. But I see that, oh, I have one real root, one real complex root. And I have 2 imaginary complex roots. Okay, and that's a total of 3. And that's what I'm expecting. All righty. Hopefully you got the gist of that, and you can pause the video and do the next one on your own. Okay, here we are again. We're going to evaluate. We're just going to plug in 3 for every time I see an X. When it says verify, we're just making sure that this goes to 0. All right, so 3 squared is 27. 3 cubed is 27. And then I have, let's see, 3 squared is 9. Negative 3 times 9 is negative 27. And then I have negative 3 times 3 is negative 9, and plus 9. Oh, I can see that this is going to go to 0. All right, so I verified it. All right, now again, we're going to find the remaining solutions to the equation. Now, unlike the problem in number 1, I could have used a different method, but I chose to use the box method. On this one, I'm not going to use the box method. I'm going to use factor by grouping, because if I can use it, I could have used it in number 1. I could have. I just want to show you there's different ways to do this. And so I'm going to factor by grouping. So I'm going to pull out an x squared, and then I'm left with x minus 3. All right, so I'm going to pull out a negative 3. And I'll get x minus 3. Okay, factor by grouping tells me that what is not in the parentheses, which is x squared minus 3, is a factor. And just one of the x minus 3s. set those equal to 0. And I can tell when I verified that if the solution was 3, then x minus 3 is a factor. Okay. So, and I can see I have that down here. I'm going to put that note is a factor. Okay, we can go ahead and set each one of these equal to 0. So x squared minus 3 equals 0. Add 3 to both sides. I'm left with x squared equals a positive 3. Take the square root of a positive 3. And you get x equals plus or minus root 3. All right, now we have our other factor, x minus 3. Don't forget this. Okay, we had an x squared minus 3, and now we have an x minus 3. Okay, so you can get x equals 3 here. So now these are, we started with a cubed function. We should have 3 solutions, and we, or 3 complex solutions, and we actually have 3 real complex solutions. This root 3 is positive, so it's a real solution. These are 3 real solutions. Okay. Let's go on to number 4. I'm sorry, number 3. Actually, I'm going to skip number 3. You can pause the video and do that one yourself. I'm going to bump down to number 4. I'm going to do number 4. All right, determine one of the zeros by inspection. If I'm looking at this function, I see I have x cubed minus 8. That's a difference of perfect cubes. So I can say, all right, just by inspection, let's see, I know that's going to be 2. So that must mean 2 is going to be a factor. Okay, or a 0, excuse me. 2 is going to be a 0 of this polynomial. But now I can prove it. So I can use this fact, the difference of perfect cubes, and I can put it into the form. Okay, so it's going to be, this is my A. This is my, whoops, it's a fancy A. All right, A, and this is my, well, not going to let me change it. So, okay, that's my A, that's my B. So I'm going to have X, same sign, because we're going to use SOAP for my signs. Hopefully you remember that. Minus 2 times A squared, so that's x squared, opposite sign, plus A times B would be 2x, and always positive B squared. So that's going to give me 4. All right, I can set these 2 factors equal to 0 now to find my solutions. And you put I 0 if you want. And then we're going to have x squared plus 2x plus 4. All righty. Here I'm going to get x equals 2. And here I got to factor this. Oh, wait, I can't factor it. It's not factorable. There aren't 2 numbers that multiply to give me a positive 4, but add up to a negative 2. So I have to think of another method, and hopefully you said complete the square. And so I'm going to subtract 4 from both sides. And then I'm going to get x squared plus 2x plus 1, because I'm taking 2 and dividing it by 2, and I get a positive 1. And then negative 4, because you got to add to this 2, right? You got to add a 1 to that 2. So that's going to give me negative 3. All right, now I can factor this piece. It's x plus 1 squared, and then negative 3. Take the square root x plus 1 equals plus or minus I root 3 and subtract 1 from both sides. And we get x equals -1 plus or minus I root 3. So those are two solutions. Oopsies. Try that again. Okay, again, I started with x cubed. I should have 3 solutions. I have 2 imaginary solutions and 1 real solution. And on your test, please make sure your test for next week, please make sure that you are boxing in your answers. Okay, let's see. I'm going to encourage you to pause the video to do 5. Do that on your own. And you should get a factor. So this is f of 1 does go to 0. So that means that x minus 1 is a factor. So x minus 1, I'm going to make that a little bit nicer. So I'm going to go ahead and use the box method for this one. X cubed minus 13x plus 12. Actually, I can't do that. I got to make more lines because I just realized that I am missing my 0x squared term. So I'm going to need a placeholder for this one. So I'm going to make this 0x squared. Now I'm going to put a column for my my tools keep jumping around. Not quite sure what's happening. All right, there we go. All right, here we go. So we're going to have now a negative 13x. And then I need one more column for the 12. Whoa, I'm not even quite sure what happened with that. Took me to a different page. All righty. Let's see. Here we go. All righty. And we get a positive 12. Okay. Have your division thought. Should get x squared. Multiply back. Negative x squared. Oh, Lord have mercy. All right. This has to add up to 0. So this must be x squared. Have your division thought. This will be plus x. Multiply back. That's negative x. This is negative 13x. So this must be negative 12x to add up to negative 13x. Have a division thought. Negative 12x divided by x is just minus 12. Multiply back. Negative 12 divided by negative 1. Multiply by negative 1 is a positive 12. Okay, now we can find our solutions. X squared plus x minus 12. That's a factor. Your quotient is a factor. And now your divisor is a factor. And you set them both equal to 0 and solve. Okay, you got to factor this. It'll be x minus 3, x plus 4, And you have your x minus 1. So your solutions are x equals 3. X equals -4. And x equals 1. Okay, we found our solutions, we found our factors, and go ahead and pause the video and do number 16 on your own. I'm just going to write the answers, the final answers. Number 6 should be really easy. You notice it's difference of perfect squares. So hopefully you notice that. I'll write the final factors and challenge yourself and see if you can get there. X minus 2, x plus 2. We should have 4 solutions because we got x to the 4th power. And then x squared plus 4 equals 0. And then x equals 2, -2, and x equals plus or minus 2i. These are your solutions. See if you can get them on your own. Okay, and then you have tonight's homework. This should be done over the weekend. You have a 3-day weekend, and hopefully you have your homework done. Hopefully the lesson helped you with it helps you with the homework. And that's it. I hope you guys have a great weekend. Bye.